All right, here comes your first day of analyzing data, but part two, and we're looking at page 2 of the statistics packet, right where we left off. We just talked about how there is a nice visual representative of a data set. When looking at a bunch of numbers, like I'm about to do in number 5, you just get a little bit weary. If I ask you to compare the 4 different locations, it might be nicer to see a visual like this box plot that's above. That's what I want to try here. What I did was, in the break, I took the liberty of ordering the data set for St. Petersburg. So I'd love for you to pause the video now and write down all the 12 temperatures for monthly water temperature in St. Petersburg in order, from least to greatest. Now that it's in order, everything we need to find a 5-number summary, we should be able to do by hand. So I want to first see if there's any other things that we should be able to find. I went in and averaged the values. I'm going to write them down for you. You just add them up and divide by 12, and I'll call the average X bar. The average of the data set is 75 degrees. So that's a good, it just says to compare the two towns, St. Petersburg and Key West, and it'd be nice to know the two averages. The modes are easy to pick out too. This one's trimodal. I'll say modes for this data. There's 3 most common values. There's 2 64s, there's 2 84s, and there's 2 86s. Doesn't tell me as much as the average told me. They're kind of all over the board. Just so happens you have 2 of each of those values. And the range we can get just by looking at the max minus the min. Like we said, 86 minus 62 gives you a numerical range of 24 degrees. Throughout the year, the water temperature is varying by a total of 24 degrees. Now that we look at our ordered list, let's do something even cooler. Let's get the 5-number summary. I'll put it way down here, 5-number summary. And just because it's the first time we're getting one of these together, let me write what it is again to remind us. So it's the minimum, each of the quartiles, Q1, Q2, which is the median, Q3, and then the max. And 2 of those things we have already, the lowest and the highest, the min and the max, you can put as the first and the last numbers in that 5-number summary. So I'll say min and max. And so we've got a 62 here, and at the very end of this 5-number summary, an 86. That'll be on our box plot too. Now for the median, right? Let's go right in the middle. So out of 12 values, let's cut the set straight in half. The median is the average of the 2 middle values. So I'll put MED for median, and then it's going to be the average of 74 and 78. So we'll say 76 is going to be your Q2 or your median, 76. All right, next, the other 2 quartiles, Q1 and Q3. If you can find a median, you can also find a Q1, take the lower half of the data set and find the median of the lower half. You're splitting this data up into quarters. So right in between the 3rd and the 4th values, 64 and 68, you've got Q1, which is the average of 64 and 68, or 66. Okay, do something very similar for Q3. Go to the upper half of the data set, average the 2 middle values of that upper half. They happen to be the same this time, so not too tough to do. And you get 84 for the 3rd quartile, 84. And this is going to be your guiding set of numbers to construct a box plot. I want to put a box plot right at the bottom of this picture. I drew a line here. Lots of times people put an arrow on the 2 ends to just note that this is kind of a real number scale. And I'll also note what these numbers represent. A good statistician would make a well-labeled graph. So I'll say this is going to be water temps, and I believe we were talking degrees Fahrenheit. And let's look at our range so far. So from 62 to 86, I don't need you to go crazy with the scale here, and your picture doesn't have to look 100% accurate as long as it's well labeled. I say let's count by 5s to get from 62 all the way up to 86. So I'll even start with 50. So 50, 55, 60, 65, 70, 75, 80, 85, 90, and I don't think anything goes above that. So 50, 60, 70, 80 degrees, and 90. So a scale on the number line, that's crucial. Next part, we make the box and the whiskers. Can you put 2 dots floating above the line, not on the line, they must float above it, but horizontally out above the scale. So at 62, I'll put a dot and I'll label it 62, so everyone knows what I was talking about. And then 86, you're gonna put a dot at the max as well. So 86, I'll put a dot. Now we're going to start constructing the box for that middle 50%. The 3 quartiles get a line at each quartile. So 66 gets a line, 76 gets a line, and 84 gets a line, like that. We're going to make a box out of this. So hopefully yours looks okay and you can connect that. And we'll label them, what do we say, 66, 76, and 84. And now to connect the whiskers, right, the 2 points to that box. So the 62 connects and the 86 connects, and you have a box and whisker plot. You can talk about the spread of the data now. Because this is such a short whisker, it actually means 25% of the data falls within just this 2 degrees on the number line. A lot of the data is from 84 to 86, and then you've got this middle 50%, and then the times that are 62 to 66. Okay, that first box plot looks ready to go now, so I'm just going to label it since the idea is to have the Key West graph float right above this one. I'll put SP just to signify that this is the box plot to represent the data for St. Petersburg. And now I'm going to look back up. Here's where I would have your calculator handy. We just calculated a 5-number summary for St. Petersburg by hand, which is good practice. I want to show some calculator shortcuts when we get the statistics for Key West. I think you're going to like this. So pull out your calculator. We're looking at the Key West numbers. Let me move myself over. And I'm looking at a blank screen, and what I'd like you to do is hit the stat key. We want to enter the numbers for Key West into our list, into L1 on the calculator. So you're going to hit stat, and then enter for edit number 1. What you're going to see in my lists is I've already typed in a bunch of numbers to help us throughout this lesson. So I have the St. Petersburg numbers in L1. You guys can just put the Key West numbers carefully as they're written into L2 and then just pause the video and then come back. And I'll be using L2 for my Key West numbers. I want to show you something pretty neat. Now the calculator will do a lot of cool things for you. It'll sort a list, which is cool because it can get it in order for you and make this process a little bit easier, finding the quartiles. It will actually cut to the chase and just find you the quartiles, which I think is great. So once you have the Key West numbers into your list, either L1 or L2, wherever you put Key West, you're going to go now to Stat and then go over to Calc, the Calc menu. Does this bring back any memories? So we've used almost all of these regressions that are in this list: linear, quadratic, cubic, quartic, maybe even an exponential once or twice. There's a couple things we've skipped over every single time: the 1 variable and the 2 variable statistics. I want you to hit enter for number 1 variable statistics. And depending on your calculator, it's either going to just show you a screen with a cursor waiting for you to tell the calculator what list you want to calculate the stats for, or you'll see a screen like this that's on my calculator here. You probably put your Key West numbers in L1, so 2nd and 1 would put an L1 here. It'll get you those values. I had the Key West numbers in L2, so I'm going to hit 2nd and 2 for L2, and I'll clear out before I do that, 2nd and 2. It says frequency list. You can leave that blank for now. We'll talk about it more later. I'll hit enter for calculate, and it's like the holy grail of statistics about this set of data. I want to copy down a lot of these things. X bar, you recognize that? There's your average. It's about 79.1. So it's taking the guessing game out of the average of a list. Use this to your advantage. If I ever ask you to find the average of a set of numbers, you can remember stat on the calculator, the calc key, and then 1 variable statistics is going to get you this awesome list. What else is there? What do we recognize on this list? Does anybody know that Greek letter? That's actually a Greek sigma. We'll talk more about it in the coming days. It means sum. 949 is the sum of all the temperatures in the list. Maybe that would be useful down the road. The sum of all the temperatures squared is this huge number. S of X and lowercase sigma of X, keep those, put a pin in these because we're going to come back to standard deviation later on down the road. But what do you think N is? N is there are 12 values in the list, and then bam, if I hit the down arrow a couple times on this calculator, it gives me the 5-number summary. I don't have to find it on my own, and it's these 5 numbers. I want to write these down. So we could get, actually next, before you write that, could you get a few things that aren't listed? So how about the modes of the data set? Any temperatures on there look like they're most common? I got that the modes were 82 and 87 for Key West. Okay, so that's good to find. The min and max, I'll write those next. So min is, on this calculator, it says 69 degrees, and max is going to be 87 degrees. So we could get the range just by subtracting. 87 minus 69 gives you a range in temperatures of 18. So you can talk about the spread of the data a little bit too. And then let's put down the 5-number summary. I'm going to list it here. 5-number summary. So it starts with the min. We already have that. So the min is 69. Q1, looking at the screen, 73.5. The median, or Q2 of the data set, is 80. Q3, 85.5, and then 87 we said was the max. So this is Q1, Q2, aka the median of the whole entire data set, and then Q3. You have max and you have min. I like it. These calculator steps get me to these solutions a bit quicker than the way I was doing it by hand. Now let's see how this stacks up to the temperatures that were in the other data set. So we'll go right to the, let's go right to the box plot. I'll move myself over here. And then I'm going to try to squeeze it up above. I'll graph it in green. We want points at the min and the max. So at 69 and at 87. 87, 69. You get dots. We're going to put lines at the 3 quartiles. So at 73.5, what's the next one? Median is 80. And Q3 is 85.5. So 85.5. And let's connect those and make a box. And you've got the whiskers too. And this will represent Key West. Like that. Pretty cool. We can now see the temperatures are generally around the same range as one another, but you've got a little more consistently higher temperatures in the green box plot for Key West than you have for a little slightly more spread out temperatures of St. Petersburg. So that is a rough overview of just constructing a box plot, and you're going to be practicing with a few data sets on your own. I just thought of something that I left out in our work here on number 5, and I have a little room to note it, so I'm going to do that now. Interquartile range. I've told you how to get it, but I haven't really interpreted it much with you. It'll be more important in tomorrow's lesson. We're going to actually use it to help calculate outliers, so just put it here for practice. It's the third quartile minus the first quartile. So in the case of the St. Petersburg data, it would be 84 minus 66. How about like that? You have 84 minus 66 and IQR of 18. What that means is the middle 50% of the data has a range of 18 degrees. Keep it in mind. You'll see it tomorrow. How about an IQR here? Oops. So IQR. Use Q3 minus Q1. So in this case, 85.5 minus 73.5. So this set of data happens to have an IQR of only 12. The middle 50% is a bit more consistent, and this box just spans 12 degrees on the number line. All right, enjoy your day. See you next time.